Okay. So, this is the link where all the materials are uploaded. You can just take a picture. While writing the link, put this underscore and everything, okay? Otherwise, you do not come. And if I go to this link, if I go to this link, you see, did you take the picture? So, this is the link, this is the link. You see, this is the theory session that we are doing today, my slides and our hands on that our student will be doing, and the data and codes she will be using all are uploaded here. Okay. So, this is the link at the top, github.com/mad dash stat/ksta capital underscore capital W workshop. Okay. You will get all the material of today here. Okay. So, let us go to the class and let us quickly wrap it up. Okay. Can you start? So, some of you will be sleepy, feeling sleepy, but anyway, today is the last day for us, only one day for us. So, I am also feeling sleepy anyway. So, under the statistical tests are performed using the sampling distribution. We try to figure out the sampling distribution of the statistic, the distribution of the statistic, that is, if we collect our all heights, if we calculate the distribution of x bar, what will be the x bar distribution? It will be normal, because xi follows normal. So, x bar will follow some normal distribution. Based on that, we can take decision, we can create a sampling test statistic, and based on that we can do test. But for us, for the application perspective, what we will try to understand, what is my H naught, what is my H1. This is very important. Based on the H naught and H1, you choose the test. There are many statistical tests. There is a book called 100 statistical tests. So, in market there are more than 1000 statistical tests available. You have to choose the right statistical test to validate your hypothesis. Okay. So, how many simple tests are there and how do we perform this test? I will just write down their name and we will perform it using practical application, because of lack of time we cannot do all the tests theoretically. So, different tests. Okay. So, there are some particular test for the mean, just like what is the average height. So, this type of test can be performed in using two different tests. So, mean test. So, that is nothing but the mean test. Mean test means, so my average height h naught equal to, my average height equal to 5 versus my average height is not 5, which is a two-sided test, because it involves greater than and less than both type of test. So, height can be greater than or less than. You can also, based on your requirement, you can also do one-sided test. Suppose I want to only check that the product specification is greater than something or not. So, this is how we can formulate the null hypothesis and the alternative hypothesis. Null is means 0 h naught and h1 is the alternative hypothesis. So, for mean there are two type of tests available. One is when variance is known, and when variance is not known. When variance is known, the test name as Z test, and when variance is unknown, the test name as T test. Okay. The test is based on Z statistic and T statistic. Now, you may ask me what is Z statistic and what is T statistics. In probability distribution, probability distribution, there are many type of distribution. One is discrete distribution, just like binomial distribution. For modeling success and failure events, there is Poisson distribution. Suppose we want to model the number of road accident happening in Bangalore, that follows Poisson distribution. Suppose I want to open a locker, I have 10 different keys, I do not know which is the perfect key. Sometime it happens, we give our keys to our friends and they do not know which one is the special key for the lock. What they will do? They will just keep on trying. Whenever it will be opened, they will stop. So, that type of distribution is called geometric distribution. So, binomial distribution, Poisson distribution, geometric distribution. These chalks are bought in the ancient time. So, that is why it is breaking. I almost broke all the chalks. So, or maybe due to the weather. So, the continuous distribution, most popular ones are normal distribution. Normality is everywhere, and then maybe Pareto distribution, exponential distribution. How do we measure the lifetime of a product? That is meant by exponential distribution. Pareto is more popular as an income distribution. Exponential is more popular as a survival distribution. If you are working on something survival of a fish, they what distribution they will follow? They will come down to something like exponential distribution or Weibull distribution. These are the probability distribution we have. These are the distribution of different random variables, distribution of random variables. Now, we have many sampling distribution as well. What is sampling distribution? The distribution of a statistic. Statistic is function of the sample, just like x bar, SS square, all these things. Sample say whatever you recall, you get the arithmetic mean, you get the variance, all these statistic. So, sampling distribution, popularly used sampling distributions are, these are for statistics, not S, okay, statistic. So, there are many distributions out here. One distribution is named as Z distribution or standard normal, or we can write T distribution, F distribution, chi-square distribution. All these distributions are the distribution of the statistic. We are not going to get into details of that, but we will understand that what is the usefulness of them in different tests. Just like if you want to do mean test, we will be using T statistic, T distribution. If we want to do mean test when variance is known, we will be doing Z distribution, we will be using that. If we want to do testing for sample variance, just like someone comes and tell the variance of the heights of the students will be 1 foot, will you accept it or not? So, if we do not want to accept it, we have to test it for variance test. Variance test. That is nothing but my H naught will be sigma square equal to 1 feet versus H1 sigma square is not equal to 1 feet say. So, variance test we can do it in two ways. One is chi-square test, another is F test. Okay. So, I have built a very nice diagram of this different test. There are many more tests. For proportion, there is proportion test, pair T test. If you want to understand some proportion, say success versus failure proportion, or the proportion of two elements, whether it is equal to this or not in any experimental design, then you will be using proportion test. But these are the commonly used statistical tests available. Now, how do we take the decision from a statistical test? We take the decision based on this guy, the p value. Okay? What is our decision going to be? If the p value is not less than a level of significance, then we fail to reject the null hypothesis. So, Just like if we build a test, where is it? If we build a test and if we see the p value is less than 0.01 of the test, we will decide what test to take based on the problem, based on the null and alternative hypothesis. I have given a case study here for which you guys have to decide the null hypothesis and alternative hypothesis. Okay? I will come to that. But how we will decide the decision? Do not look at those maths and get feared. So, just look at this. If p value is less than 0.01, we will say we have very strong evidence to reject H naught. What does that mean? We are almost 99% sure to reject H naught, still 1% losing, right? Sometimes that may affect. If p value is less than 0.05, we say we also strongly reject H naught. That is very strong rejection, that is strong rejection. Now, if p value is 0.05 to 0.1, that means I am more than 90% sure, but not 95% sure. So, I may not reject H naught, but in some medical study, in some other discipline, sometimes the acceptance region is 90%. If you are 90% sure, that fine. And in some biological study, they say you have to, your p value should be less than 0.01 to get the paper accepted. Now, this is a very diplomatic situation, right? You are not 100% sure one thing, you are doing some experimentation and you are telling if p value is less than 0.05, I will reject. What if p value is 0.0501? What you will do? You will not reject, right? You are going to accept it, right? But this is not the case, right? This should not be the case. I just lost one paper for 0.01. So, you will not be publishing the paper then. That is why there is something called nowadays in many studies, p value is not the determining criteria, but still majority of the journal they follow the p value things. There have been a lot of write up recently in Nature, they are published one paper that dilemma of p value or something like that, or the end of p value, something like that they written. They projected so many experiments in which p value was very close to 0.05, but that was full on the borderline and their decisions were wrong. That is how when you are using p value, be diplomatic in sometimes. Maybe you may get some higher p value, but that may be due to some particular incidence in the decision making process or data collection process. And when p value is greater than 0.10, you mostly not reject H naught. Now, you see there is something we are deciding on H naught. Are we ever telling accept H1? No, because H naught is the person whom I have to convict, right? He is the person, right? I am not telling I am going to put someone behind the bar, that does not mean another person is correct, right? That person is under the jurisdiction, not the police officer who took him. He will not get anything, right? So, every test is to decide whether to reject or accept H naught, or not to reject H naught rather to say. Okay? So, now I will pose a problem and we will try to see how we can form H naught, H1 and the test statistics. If we do, what is the result we can get, maybe theoretically first, then practically. Okay? I will go a little faster, we have some more things. There I wrote all the tests, Z test, T test, chi-square test, F test. Okay? All these tests assume that the data follows normal distribution. If the data does not follow normal distribution, there are different tests available. Okay? But majority cases in most of the other discipline data sets, they usually assume the normality. But if does not follow, there are also many tests available for that. I will directly go to the example. I will escape the mathematics here because of the timing, but if you are interested, you can go through them, and I also suggested a book in which all these things are very clearly explained in details. So, I will go a little bit and then come to the case study. Okay? So, this is a very interesting case study. So, a coffee vendor nearly Yashwantpur Junction station, you all know this station, right? When I first came to Bangalore in 2014, I landed to Yashwantpur station. I did not have money that time to come with aeroplane. So, I came here to study. I have an interview at ISI Bangalore. So, but ISI Bangalore used to pay for two AC 2 tier or something, tier 2. Nowadays I don't travel by train too much. I forgot. I think 2 AC or something, 2 AC or 3 AC they paid, and with that money we came. So Yeshwanpur Junction railway station has been having average sales of 500 cups per day. Okay. There is a vendor, tea seller. Nowadays PhD tea chai wala and all these things are coming around, right? MBA chai wala, sorry. Because of the development of a bus stand nearby, it expects to increases the sale. During the first 12 days after the inauguration of the bus stand, the daily sales are recorded. So 12 data point is not sufficient to make any statistical conclusion. You minimum need 30 to 50 samples to make the statistical conclusion, but this is for the example. Don't take it like really in your experiment, don't just collect 12 data and make the statistical test and decide, okay. So collect more data sets, okay. On the basis of this sample information, can we conclude that the sales of coffee have increased? Consider 5% level of confidence, that is if p value is less than 0.05, reject H naught, that is be 95% more than 95% sure with your decision, okay. So how do you formulate this problem? Can you tell me what is my H naught? Average? So that is some mu or something equal to 500 versus what is H1? Yes. Do you agree with him, all of you? So we are going to understand on the basis of sample, can we conclude that the sales of the coffee have increased? What was the average sales for first? 500. Increased means it should be greater than 500. So what we are going to test? H naught equal to mu equal to 500 versus mu greater than 500. Is it clear? This is how we form a test statistic. This is how we form a statistical test. So any statistical test follows this 5-step procedure. I have written it by like just like step. So first you have to specify H naught, then H1. So here I have specified my H naught and H1. Then determine the sample based test statistic. This is a mean test. What is the test statistics we are going to use? Tell me. T test, right? Because I don't know the variance, right? I don't know, any variance is not given. So I will be using T statistic. Then collect the data that we are already given here, make a decision to accept or reject H naught and interpret the result for the vendor. So the chai wala ko jaake if you say that p value is 0.03, so he will say just go from here. You will not get even a single tea. Money to bhuli jao. So you have to tell the chai wala ki dekho bhai, I have observed for next, don't observe for only 12 days, observe for 6 months, and you tell bro, the bus station is not going to help you. You are thinking that your sales will increase, you are buying more product for the bus station, but that's not happening. I have understood your problem. Maybe if you do it for MBA chai wala, you may get some money, okay, or chai point or something like that. Too many people are selling teas, that's a good thing. So this is my H naught, some mu equal to 500 cups per day. H1 is mu greater than 500, and we are given the acceptance level is 0.05. If I get p value less than 0.05, I will reject H naught, okay. If p value is greater than 0.05, I will not reject H naught, okay. Let us come to the problem and calculate. So we will do a T test. T test statistics looks like this. So when, because you are not from statistics or maybe core computer science or mathematics background, for you, you may not need to know the what is the exact test statistic, but if you apply it for your own research work, you should be at least looking at what is the test statistics and everything. Otherwise, some people they give answer like this, computer ne de diya mujhe. I put the data out there, they give the answer, I don't know, don't ask me, ask computer. This is not the answer you are going to give it to your examiner or the person who will be looking at your paper, right. So many a paper, when I review a hell lot of paper regularly for many journals. So I see many a journals, they when writing, they will write I use R statistical software or this statistical software or this particular black box to compute these values. and they will write like that they don't know what is the procedure even that is used. So, if you write your paper like that, another person who is reading, they will feel like you are using some black box, it is all magic is happening, right, and you do not know what is inside the magic. So, if you are the magician, you should know what is inside there, right, if you are using it. So, that time you have to look into. For now, okay, we figured out that it is a mean test, its a variance is not known, we are going to do t-test. Okay. So, t-test, what is the result we will get? Let us see, let us figure out that. So, I wrote each and every procedure here how to do t-test. Okay. So, maybe for now you can like forget it. So, suppose I got my t value to be something like 3.6 and which is greater than the expected t value. That means, I got something like this. So, here p value did not come actually. So, here what I calculated by hand, what is the observed t value and what is the tabular t value. If the observed t value is greater than tabular, then we reject H naught, that means p value is less than 0.05. If we run this simple test in RStudio that you have all installed by now, so if we do that, then the p value might be coming here 0.03. So, we will be rejecting H naught. So, this is how we can, but when we do it by hand, we do it in a different way. Instead of calculating p value, we calculate the t observed value. The observed value of the t statistic, if it is higher than the tabular t value, then we reject H naught. So, here if we reject H naught, that means what we will tell the vendor? I will go to the vendor and I will tell, dekho, the next 2 weeks data does not say that the sales value has increased. We reject H naught, right? H naught is mu equal to 500. That means mu is not equal to 500, it is greater than, right? So, I will tell that, okay, sales figures increase हो रहा है, अभी और एक auto stand आ गया तो मालामाल हो जाएंगे, ठीक है? So, you will be more richer after a few days, right? So, this is how business decisions are made sometimes. This is a simple example, but there exists a hell lot of example in which you can understand the application of these things, the statistical test that comes into picture. Now, maybe after a few slides, I will just push off and Madhurima will show some example, more example. Now, there is something called ANOVA. I will just tell when it is useful. Suppose I want to understand how is the students level in Bangalore. So, how many bachelors in technology colleges are here in Bangalore, do you know? Too many, right? 100 of colleges are there. I want to see their level, I want to compare their final year students level. So, what I collect? I go to all the colleges, I take there all the final year students marks. Okay? Now, I want to compare which college is good. How do I compare? How usually we compare a student is better than another student? Results. That is the that is the more tangible way to do that, right? Which is not the best way, of course. Okay? कोई student ऐसा भी हो सकता है कि the person is getting very less marks, but he is doing very good in life, right? So, based on that, what I will do? I will take all of their marks from different colleges and I want to compare their mean. So, I will test H naught equal to mu1 equal to mu2 equal to mu3 equal to mu4 for 100 colleges, whether they are equal versus they are not equal. That time we use some test called ANOVA, analysis of variance. Though it is actually the test of mean, but we call it analysis of variance because we try to also understand the variation among the mean. Okay? So, this is, we are not going to get into details of ANOVA for today, but I will come down to something which is more interesting than this, which is called the relationship analysis. Now, after studying this your height data, enough of heights, now you want to understand, does height correlate with weight? What would you say? जिसका height ज़्यादा है उसका क्या weight भी ज़्यादा हो सकता है? हाँ? कुछ लोग बोल रहा है yes, कुछ लोग बोल रहे हैं no. So, it's not necessarily, but what if you look at in a population? So, mostly those whose heights is taller, they will have more muscles, right, in that sense, or haddi जिसको बोलते हैं, right? The bones will be more stronger maybe, they may have more weights, may, okay. If we want to see whether it's true or not, how would you like to see? Now there are two variables, okay, and we want to understand whether these variables are related or not. Related means अगर किसी का height बढ़ गया, if the person has more height, the person has more weight or not, or if the person has less height, the person will have less weight or not. So this is what we called understanding the associationship between two different variables. This is measured by, mathematically measured by correlation coefficient, okay. So we will try to see an example of that. So this is a data of wage, a large data regarding the wage for a group of employees from the eastern region in India is given. In particular, we wish to understand the following: employees age, wage is given, calendar year is given, employees age and education is given. If you collect the data of any employee's wage in Infosys, in Wipro, and write down their education thing, would you see those person who have done PhD, they are getting more wage? It's not necessary, right? Education and wage doesn't matter. It may matter for our data because we are showing example and we are trying to motivate you for studying, but in general the MBA chai wala thing, right? So it doesn't matter sometimes, right? But in developed countries it matters. In America and many other countries, Europe, sometimes the wage is dependent on the education qualification, okay. But wage is dependent mostly on the number of hours you work, in Infosys maybe, but that also in India doesn't work. In India, people who are getting lowest wage, they are working more, right. So but our data, whatever data we have collected, let us see what is showed. Wage versus age, we plotted. Can you tell me what can you conclude from the data? This is their age from a, maybe there is an exceptional guy who got job at 18 years and he is getting monthly 50k, and someone is getting up to 300k per month. That's a lot of money, 3 lakh. So their age is given and this is their wage. What can you conclude from this data? In between 40 to 60 maximum wage. Can we tell, abhi now you see, if we draw a straight line, it will come down up to here, then here. So maybe with age the wage increases up to 60 years. This is true in India. After 60 के बाद people have retirement, right? So जो military में था या कहीं पे भी था, they will come down and work for less money. This is the case in India, right? Not always, but yeah, some cases. Maybe if you are a professor, you will become a professor and you will work in an institute up to 60 or 65. Then after that, they will throw you out and they will put you as a visiting or adjunct faculty, right? And they will give you, बोलेगा कि monthly जो ये क्या बोलते हैं compensation मिलता है, you will get something like that, and some small money regular basis में talk दे दो, 1000 रुपया दे देगा तो पकड़ लो. So you are going to lose money, right? So it may be happening as a professor job maybe. एक professor का suppose age दिया हुआ है and OS दिया हुआ है, वो पहले suppose ये जो है वो tuition पढ़ाता है, give tuitions, maybe they are on a small age, but then once they are getting PhD and getting things, they are getting lot of money, then decreases. So we can say there is a relationship between wage and age in the sense from 20 to 60 wages keep on increasing, but not very strongly, right? But then it keep on decreasing, right? So this can be more mathematically presented as a correlation coefficient. Using correlation coefficient we can try to understand that. So this is if we have to draw a line from here, so maybe एक curvature बन जाएगा ऐसे. We can make a line, not a straight line, using this particular thing. So on the average wage increases up to age 60 years, at which point that after that point the decline begins. Now wage versus education level. ये education level है, this is say high school, college, university, PhD, postdoc, ठीक है. Maybe for our data is showing if you do a postdoc you will get a better job, but after postdoc if you join same university you may get the same job, maybe your grade ऊपर देगा थोड़ा. So, they will put grade 10 to grade 12 or something like that, right. I do not know the university here how it works, but the wages are given. So, what you can conclude, that education level has a significant importance on wage. Based on the education level, your average wage actually increases. Okay. So, how do you do it mathematically? So, this is mathematically done, can be done by building a relationship analysis. Given an employee's wage, can you predict his age? Now, if I can, based on that line, if I can draw an equation, if I can write y equal to some x, then if I put the x, I will get the value of y. So, then if I make a regression equation, then I can actually predict their age based on their wage, or the opposite way. We will see which one is dependent on what based on that. So, suppose we are given with a data like this, we are given a data x, y like this. I ask you a question, if we have to store this data, we need a Excel file, right. Excel file will take a lot of memory. So, how can we store the data using a very minimum memory? Can you come up with some idea? Without storing the whole data in the Excel, can we store only one or two values which will represent this data? Can you tell me? So, I think many of you has studied geometry, right, in school, right, high school or school, geometry, basic geometry. So, if we draw a line, this is x plane, this is y plane. We can write the equation of any line as y equal to a plus bx or c plus dx or something like that you written, right. You have written this, right. School you have seen this, I am quite sure. Y equal to a plus bx. Why? Because if you put one x, x equal to 1, you will get a plus b some point. You need to know the a, right. Now, if I draw a line here and find out this a and b, say a equal to 2 plus 3x, then I do not need the whole data, I just need this equation. Am I correct? This is called regression analysis. This is known as regression analysis, this is known as linear regression. Okay? Whenever we have one x and one y or multiple x and one y, then also we can write y equal to a1 x1 plus b1 x1 plus c1 x3 like that. Okay? So, this is called linear regression. Suppose you want to express your seed production in terms of the amount of fertilizer you are giving, you want to see the relationship between them. So, your seed production y equal to will be alpha plus beta x. Then you can say, if you know alpha beta, then in future if another farmer come to you and say I am putting this much fertilizer, you will say maybe your seed production will be like this, crop production will be like this. Okay? So, this is how you can make a model. This is called statistical model or regression model in modeling techniques in statistical data analysis. So, just like this. Okay? Now, how A and B are chosen? This is the most important crucial thing. So, we are here assuming that these values has a strong relationship. Why? Because we can see that there one is increasing, another is increasing, one is decreasing, another is decreasing. This is called correlation. This is called correlation. If one increases, another increases, that is called positive correlation. If one decreases, another decreases, it is called negative correlation. If there is no correlation, you cannot see anything, that is called no correlation or zero correlation. Okay? So, this is how we do the correlation analysis and regression analysis. I have given a lot of examples here, I have given the definition also. So, the value of the correlation coefficient lies between -1 to 1. Negative means highest negative correlation means y equal to minus x, and y equal to x means positive correlation, okay, plus 1. So, this is the mathematical definition of correlation. Covariance is nothing but the variance between two variables. Earlier we have been studying the variance between your heights, now the variance between your height and your weights. So, that is called covariance. Covariance over standard deviation of x and standard deviation of y. So, we have a data here for which this is a very interesting study that got published in PLOS 1 or something like that. So, data on coronary heart disease and cigarette smoking in 21 developed countries they collected, and the data has been rounded for computational convenience. They have a data like this. In different countries they have checked the cigarette consumption per day and their this is cholesterol, right? See what is CHD? Coronary heart disease, right? Coronary heart disease, right? Yeah. CHD mortality, okay. So, if we plot this data, we can see there is a very strong correlation between them. You see, as smoking increases, as you smoke more, so does the coronary heart disease mortality increases. That is why in cigarette things they write that smoking causes cancer and all this, smoking is injurious to health, right. So, this is how people came up with the idea whether smoking causes really that thing or not. They have to take the data so that there is a strong correlation between them, okay. And now if someone asks you what is this relationship, you have to get the equation of this line. This line is known as y equal to alpha plus beta x, that needs you to calculate alpha beta. That Madhurima will show how from software we can calculate it. The method that is used is called again the least square estimation method that Gauss invented in the 1800th century, okay. He invented it much earlier before the regression came actually. So, this is how we can compute it and it works perfectly. Now, I will show you an alternative example. You can see some things are moving, right. Those who felt sleepy, they may wake up and see this dinosaur, okay. We are showing some dinosaur example. So, I have some data, I have some x's and y's. I calculated their mean, I calculated their standard deviation, that is root over of variance. I calculated their correlation. You see all of them have same correlation, but their picture data changes. You see all on a sudden dinosaur type of thing came. This is called data Swaraj dozen. 12 different pictures are getting generated based on the same data, based on the different data with same mean, same standard deviation, same correlation. That is why sometimes people say correlation is not causation. That is why there were a lot of examples like that. Suppose in India I observe number of divorces and I observe the share prices and I see that there is a very strong relationship, then I should say people get divorced, then my stock price will be higher. Should I am going to say that? No. That is why, or maybe if you see the stock price is increasing, along with that the number of cigarettes sales are going to increase. Can you say that stock price depends on cigarette sales? No, right. That means causation. Causation means one is causing another thing. That is not always equal to correlation. This is an example, exceptional example, when correlation, you see this data set has very little correlation, minus 0.06, there is almost no correlation. But if you plot the data, if you get different data with the same mean and all these things, your different data sets show different pictures. That is why sometimes this type of plots, correlation plot, or which we call in statistics scatter plot, may not be too much impactful, but it is impactful many a times, but you have to understand what are the variables. You cannot just plot two different variables and publish a paper, see divorce is going to be correlated with his stock price or something else, right. That people will not understand, okay. But if you show that crop production is correlated with fertilizer, the amount of money you invest to buy the fertilizer, there might be a correlation, or the amount of food you give and the amount of body development it happens, it might be correlated, right. There is a very strong study that Abhijit Banerjee got the Nobel Prize, right, in economics. Professor Abhijit Banerjee from MIT got the Nobel Prize with Esther Duflo, his wife from MIT economics, Nobel Prize in economics 2020, right. They published a study in which they found a relationship between nutrition level of Indian people and their food habits. and they did a randomized trial with Indian people, Indian suburban and वो जो बस्ती को क्या बोलते हैं the slum areas people, and they found a strong relationship ki your nutrition level affects your body development. That is why in African countries the nutrition level is so poor that people are undeveloped sometimes, right, in Congo and many other places. So, this type of studies are very impactful. So, this is the correlation analysis. If you see the plots are going in the straight line direction, this is positive correlation, negative correlation, no correlation, and all these pictures I have given. Then this is nothing but simple regression. Then I put a very interesting picture. This is Galton. Again the Galton guy came, Darwin ka step brother jo hai. So he developed another thing called Galton's board. This is available in Amazon. You can buy it with 500 rupees. If you have some small kids in your house, you can teach them how normal distribution is made. You see, you throw some thing and it becomes a normal distribution. It shows that binomial distribution for large n, for large sample becomes normal. Okay. So any distribution converges to normal distribution. This is an example of central limit theorem. That is why normality is very important. Any distribution, if any data, if you collect more data, it will become normal. Any data, long run may everyone will be dying, right. So economist says in long run we all are dead, right, that is true always, right. In long run we all will be happy because we will be dying, right. Short run may we are facing lot of problem, we are anxious, we are having mental issues and all these things, other issues, physical issues, but in long run we all will be happy, right. So just like that, in long run if we keep on collecting more data for n very large, number of samples very large, it will become normal distribution. This is one example of that thing. This is you can buy it in Amazon, maybe if you are interested. Now this is the linear regression. Linear regression is y versus x. I want to build a model y equal to alpha plus beta x. How alpha betas are chosen, we are not getting into the maths. Our software will be doing if we give 1x and 1y. Now some people must have slept after the food. I think the food was so good that some people are having good sleep. So I will just come to the almost the last slides, and then Madhurima will hand over. Some of you will be interested to do some practicals. Maybe you can try your hand with some real data that she will be providing you. So I am not going to get into the details of this mathematics, but this is the relationship that we can find out. This is the line equation that we can find out using the R software. Linear regression equation between CSD is equal to alpha plus beta into cigarettes. So this is going to be my equation. I am coming directly to the equation. So based on some mathematics, we will get some equation like y hat equal to, that is CHD equal to 2.367 plus 2.042 into cigarette, number of cigarettes one smoke. So this is the equation we will be getting out there. Okay. So that is the equation they plotted. So now I am going to give you a 5-step procedure with your data. If you have any data, how do you build a regression model, how do you build a statistical model using your data. So you look at the plots, look at the descriptive statistics, whether it is linear or non-linear, try to figure it out. How many x's you have, you try to look at them, whether your x is y is discrete or whether it is continuous, you look at them. Then you build a model and try to check for the residual. Residual means after building the model, you check how close your model with your actual values. Okay? Just like previous cases. Suppose you make a model for forecasting the temperature tomorrow. Your model yt, suppose yt is today's temperature equal to alpha plus beta into yesterday's temperature. So you have to check it whether it valid for earlier days or not, right? How close your model is with the previous test. Now I put a few cheat sheet, maybe this will be useful for you. What are the type of data visualization tool you have to use based on your thing? Sometimes comparing categories with same measure or the same within the same measure, bar chart is very useful like this. line plot when it is useful, pie chart when it is useful, waterfall chart, geographical chart, box plot, histogram, all these things, scatter plot I have written when to use what based on your data. So, it is like a medicine. Okay. So, if you have fever, then go for Calpol, if you have diarrhea, go for some other like that. Okay. So, it is just like a simple chart to use for you to use. Now, what statistical test to use? When you have mean test, you see the mean test, normal distribution, you use t test. If you have multiple group, use ANOVA test. When you have non-parametric case, for median you use Wilcoxon test. For dichotomous variable, univariate, multivariate cases, what are the tests you use? Based on your data, you just choose what are the things you have to use. So, it is better if you just learn this subject more carefully, because finally all sciences at its analysis is statistics. All sciences, everyone is like presenting their paper, whosoever is writing any paper which is application oriented or which is experimental work, they are finally using some or more or less some statistical or machine learning tools at the end, and that is what making their paper to be published in big journals. Like you may some sciences, PLOS is a good journal, PLOS computational biology, some is like Nature Communication, Nature Scientific Reports, all these journals people are publishing just with not only with their thing methodology, but also by applying their usefulness using statistical analysis. Data can be of various type. In data science there are many type of problem exist. We are not going into details of that, maybe sometime I will get more time and I will talk about it. Now, based on the what is your dependent variable, suppose I want to understand the chance of having cancer after how many cigarettes, if we if we smoke every day, we are having the highest chance of getting cancer. So, that numerical variable is the cancer, like chance of getting cancer, and independent variable may be number of cigarettes. So, if both are numerical, you can use linear regression. Many other methods are there, logistic regressions are useful for categorical dependent variable, and many other methods are there to be used. Whatever data, based on the data, the medicine will be suggested. Now one may ask me, what is the book that we refer to study all these things? This book is very nice. It is written by that guy, Alan Agresti, whose picture I have shown as Barack Obama's father, number A. Okay? That is the guy who wrote this book. If you find this book very tough and you like more YouTube videos than other things, nowadays people like YouTube videos, then go to the channel called StatQuest channel. This is by one of very nice guy whose name is Joe Stammer. He also wrote a book called StatQuest Illustrated Guide to Machine Learning. He starts with statistics and talk about linear regression, all these things in with very easy example, A plus B and like that. He will add 2 plus 3 and then show the example. He is very nice in description. You can just go to your YouTube and not now and search StatQuest channel. Okay? And he has videos on everything, all the topics I taught, descriptive statistics, ANOVA, linear regression, all these things he has videos. Okay? And this book is like the slide of the videos. Okay? The slides that he is using in the videos, that is presented in the book. You can buy this book, this is available as well. Okay? Now in India, if you are like more of a pro who studied statistics earlier, but now want to get your hands more into machine learning and all these things, this is the most fundamental bible of machine learning, which is called Introduction to Statistical Learning. You can also try this book. Okay?
And since this is printed under 2 single quotes, R will understand that it is a text and it will allow this space over hit, otherwise that space will not be allowed. So, once you hit hello world, you can see that in our console the hello world is getting printed. Now, I will try to do some very, is there any problem? Okay. Yeah. Now, we will try to do some very simple mathematical operations. So, basically if you try to add 2 numbers just as in calculator, you can just write 3 plus 5. In R also you can write 3 plus 5, and to run any code you have to go up over here. You can see there is a run option, just press this and it will run. So that is it. Now you take some complicated mathematical expressions also. If you take that and if you try to run it, it will run. Now we know there is a function called pi, right? In maths we use it very often. So in R is a very user friendly software basically. So if you want to recall the value of pi in R, we just need to call pi, that means pi, and if you just write pi over here and press enter, it will give you the value of pi that is stored in the R working directory. So you just write use this function pi of into 2 to the power 3 and try to calculate its value. So this is what you are getting, and I will try to skip some of this. So like it's factorial, we know factorial, we can have log. Now working with an assignment. So previously what we did, we tried to sum two numbers. Now what if we want to save that number into a variable? So for doing that we have to assign some sort of a variable to that number. So here what we are doing, we are assigning x, which is at any quantity. You instead of x you can give a, b, whatever you want, but you have to give some sort of letter. You cannot give any numbers in it while doing an assignment. So if you write x is equal to 3 plus 5 and then you try to print x, it will be giving you 8. Similarly, if you take some other mathematical operations, it will be giving the same thing. Now it is very important that R is a case sensitive. So suppose you are assigning some operator a as 6 plus 8, which is a is capital, and then you are trying to print small lettered a, then you will see that object a is not found, because R knows that capital A means 6 plus 8, but it does not know what is small a. Now if we try to print capital A, then you will get 6 plus 8, which is 14. Now if we try to, so in the last thing what we did assigned some value 3 plus 5 into a variable x. Now what if we want to store a vector? Vector is nothing but a large number of values. So sir was telling about some samples. Suppose I am taking height of all the students over here, so and want to save that, I have to take the height and have to save it somehow, right? So we can save it like using a C. C is nothing but a concatenate operator. C just creates a vector out of it. So I am writing data 1, that is a vector, and I am assigning data 1 as a vector with all the values that are available, and now I am trying to print what is data 1. So these are the values that are available in data 1. Now along with data 1 I want to put some sort of text in it. Maybe I want to include what is Thursday and Friday in it. So there again you will use the C operator, but just as I told you earlier that for any text you need to put it inside quotation mark. So similarly we just put it inside quotes, and now if we print data2.text, then we will have all the values that were in data 1 along with Thursday and Friday. Now apart from this we have a scan command in R. So what happens in a scan command? If you just pass through a scan command and just say that that command will be including some characters, that means you will be passing through some letters or some text through it. So once you do that, you see one and a semicolon is coming. That means whatever you will be passing through this 1 or 2 and all that, that will be included as data 3. This is actually an alternative version of what we did in the previous thing, where data 1 will actually written in the form of C, that is a concatenate function. So if you run this entirely and then you try to print data 3, you see it is still going on. Now if we try to understand what was the value of data second term in data 3. So if you try to do that, just a minute. this is the value that is available in data 1.
So R can be used as a calculator. Okay. What are the calculations you do in your calculator? R can use. It's better to see some example with example with real data first.
Yeah.
How to enter the data?
Yeah, I am coming. Yeah. So, some of you were asking about how to load data in R, right? So, for loading data, it is very important to check what is the working directory. So, in our normal laptop or computer also, we also always check what is our working directory. So, for checking that, just pass the command get wd, that means get working directory, and if you pass that command and run that, you will see that for me now the working directory is in the D drive and it is data and code, and every one of you should have the working directory as data and code, then only we will be able to run it. If you do not have, then we have to change the working directory, because our data are actually stored in this data and code folder, and we have written the our codes over here in such a way that we will be able to draw the data from this data and code folder. If we are not having our working directory as data and code folder, then while calling the data we need to change the data path. So, please ensure that your working directory is this. If you do not have this working directory, then use this setwd command. Use this setwd command, and inside that just place the location of this data and code folder in your computer. Okay, and then you pass it, run it, and then check the current working directory. So, any one of you have a different working directory either like other than this data and code? Okay. It's okay, we can take a 10 minutes break, we will be back by 4. Okay, okay. Fine. Okay, so all of you have this working directory, right? Okay, that's good. Now we want to check that what are the elements that are available in our working directory. For that, we use this dir package, dir function. Dir means directory, okay? So, once you pass this dir function, yeah. So, should I proceed? Yeah. So, once you pass a dir directory, whatever is saved in your data and code folder, that will be listed. So, as you can see that there are different CSV files which we will need in our practice session, and we have this practice.r, which is the R file that we are using. So,
okay, so you have a question how to import the data, right? You have some data, so you import the data using import data, right?
okay. Yeah, but I haven't come to that yet. I am coming.
No, don't need this arithmetic operators.
Okay.
They are more interested to see the report. These things will take a lot of time. Yeah, you come to this stage. So now we will import the data. In your data import folder, there is a data called credit card expenses.csv. Can you see it in your computer in data import folder? Not in R, in your data import folder.
Even in your R folder, once you go to this files option, you will be able to see this credit card expenses.csv.
Can you see it?
Yeah? Okay.
Now how to install it?
Just right click on it and you will see that import dataset option.
Can you see it?
So, once you press the import dataset option, you see there are some library called read R, and you can just copy. There is some code preview, right? Code preview is there. You can just copy that code. Select it, copy it, and just paste it. So this read underscore CSV file we actually use to import .csv dataset. Okay, whenever we have a comma separated file, we will be using this. If we have a table TSV, then you will using read.tsv like that. So based on that, you can just find it in the help option. Whichever you want to use, you will be whatever is your folder quality, you will be using it. So now our data is actually saved as credit card expenses. I think for all of you it is saved as credit card expenses. Now if you just want to check how the data looks like, you can just run this code, write the name of the data frame and run the code. So this is the data set that we have. It has two columns, basically month and credit card expenses, that is CC expenses. Now if we want to, since you can understand that credit card expenses is a big file name and we want to change the file name to my data, then we just assign it to a different file name, that is my data, and if we print my data, we are going to get the same thing. Now suppose that we want to read a particular column or a particular variable from the data set. So we can do that by using this dollar symbol. So basically our data was saved in my data, and this dollar symbol that you can see right over here will actually extract the CC expenses column from my data, and the assignment operator, that is CC is equal to my data dot CC expenses, that it will actually save the CC expenses column in CC, and you can change the value of name of CC to anything you want actually. So just to run this code, and then if you try to print it, now it is printed not as with the other column month, only you have the CC expenses, nothing else. Now like just before, so I discussed about different descriptive statistics measures like mean, median and mode. So all of these can be computed in R very easily. There are just 1 or 2 lines of code that we are going to use. So if you want to compute mean, you simply pass that variable through the mean function. Yeah, so any one of you have any doubts? Yeah, please tell. You are getting it? Yeah, you didn't run the previous lines of code, right?
Okay.
You have to run the, you haven't imported the data itself.
No.
No, it's not imported. Okay. Now if you run it, just I will show you. Yeah, now you're getting, right? Okay. So you have to run sequentially. You have to run each and every line of code. You also didn't run the data itself. You have to first import the data. Now if you run, it will work. Yeah. Can just pass the laptop. So basically, you just see, these are the code previews you have, right? And you, sorry. You just copy this. Yeah. Paste it over, just a minute. Yeah, here. So you have to run. Here you have to run. Here you have to, you can just press enter, it will work. Here, library. It view means the data set will be viewed in a different notebook, but we don't need to view it differently. We can just view it over here, and here we are saving. No, we don't. Yeah, you just type your code or let your code be here and run from here. It will be coming automatically to the console. Okay, and you are saving it to the my data. And now if you try to extract, it will work. So you actually didn't import the data. That's why it was failing. Okay. So I will come from that side. So this is the data. I'm sorry. I'm trying to using the import data set. Required packages versions will only found if it's yeah. Read.csv. Credit card. You have installed this now? Okay. Yeah, it's working. Okay. Yeah, so there was some problem with readr package. Okay, so instead of using that, I directly wrote the command whatever was coming over there, because there was a problem with here. So you can see over there also they are using the same function, read.csv. So we use the read.csv itself, and then when we run the code, now it is working. So you can run the rest of the lines, it will work. Just try. resource. Where is that file? Can you just open that folder? Over here. For you also it's not coming? Just a minute. Now on the work, you have to set the working directory. Yeah, please show it to me. For you also just a minute. I already read that file. Why you are trying to reload it? Yeah, you are again running the import function, right? Read.csv will read the file. That means it will import it. So it's of no use to import it consecutively. And what you are doing over here, you are passing the credit cards.csv within just quotes, and you are not giving anything. So this entire thing is actually being treated as a text. So how we printed the hello world, it is also getting like that. Just run this, no? Yeah, excuse me. It's working, right?
Yeah.
This is your working directory, I guess.
No, I didn't do.
So what is your directory now? So just since you will be using this as a working directory and it is always be open, just go to more and use the set as working directory option. I have already done it now, so now you don't have to do it. But for later, I'm telling you.
Then just click on it.
Yeah, then you can just run this all the descriptive statistics things, that read card, credit card expenses.csv data, and it will work. Okay. So for others, I guess you are able to follow. Sorry. Yeah. Just let me come to it. So I will just proceed. Okay. So, I think many of you could be able to do this mean, median, standard deviation, variance, minimum, maximum, range, quantile and print. So, till now whatever we did, we used different functions. We used min for minimum, max for maximum, mean for mean of or the average, right. So, what if we want to get these values for a large number of data set, then we can't go on writing this each and every time, right. So, in those cases we can use a simple function called summary. So, what happens in a summary, whenever you pass a variable through the summary function, it gives the descriptive statistics, all the descriptive statistics that you have heard about till now, those gets printed in the summary statistic. So, what it is giving basically, you remember the box plot which Tanujit sir said you, that we will be having the mean, median, then quartiles, first quartile, third quartile, maximum, minimum, like that. So, basically when you are passing the summary function through it, we will be getting the box plot, whatever was given in the box plot, the same things will be passed on and will be created over here. We can use a different thing, just a minute, yeah. So, there is one more variable that is one more function that is available other than the summary, that is a describe function. Now, before coming to the describe function, I will be telling you how to import packages. So, till now we have been talking about a lot of packages, right, that whenever we are working we need some sort of packages. So, basically there is a lot of packages which have been already created in R. So, you learnt about linear regression today. So, while doing linear regression, you do not have to do all the mathematical calculations and then you are coming to the values of A and B. Okay. So, what we can do, we can use some formulas that some other people have actually uploaded in the R web page or the R documents, and where they have uploaded those formulas into different packages. So, there are different packages for different functions, like there is ggplot package, ggplot, which is actually used for plotting, maybe scatter diagram, box plot, then histograms, like that. So, whenever in our study also, in our research, whenever you are doing some research work, we actually try to build some packages so that whenever people are using our models, they do not have to do all the coding from scratch. They can just use our package, they can take the data, their data and pass it through our formulas or the functions that we have provided in the package, and they will be getting the desired outputs. So, for working with packages, what we need to do, we need to first install the packages. How we are going to install it? I think all of you have this install.packages and psych, right? And there is a space and a hash before that, right? And it appears in green. So, can any one of you tell me why it appears in green? Others are not appearing in green other than the another way to calculate descriptive statistic. Why it is appearing in green? Any just random guess will also work. So, basically it is appearing in green because it is being treated as a text, not as not even a text, it is a comment. So, whenever we are writing some code, we have to comment a lot of things so that it becomes explainable for others. Like here what I have done, I have written a sentence like another way to calculate descriptive statistics. If I haven't written that sentence, I would know that describe is actually used for calculating another thing in descriptive statistics. But you as beginner, it is very difficult for you to understand that why we are using this describe, where it comes from. So, here this line, that another way to calculate descriptive statistics, actually works as comments. So, whenever we want R to not run some codes and not take something as an input, then we pass it through a comment. And how we pass it through a comment? We just include a hash. A hash function, whenever we include a hash before any text or anything like that, it will be taken as a comment. And even if we run that run the function with the hash, anything with hash, it will not be run, it will just print as it is. So, if I run this, don't run this for you guys, if I run this, Now you see in the console what it is doing, it is telling it is just running install.packages, but there is no output, it is not generating any output. But if we have to install that package psych, what we need to do, we need to first omit this space and this hash. Now it actually becomes a code. This one I am talking about, that blue highlighted one, and the install.package, this option, this function install.packages function is actually used to install the desired package, and once the package is installed in your R, now next time onwards you do not need that install.package, what you need is a library function. So basically you have to call it, you do not have to install it, but you need to call it so that it becomes usable. So try to run that install.package after removing the hashtag and try to run the library, that means you are calling the package, and just see that if is it working or not. Anyone is having any problem? It's working, right? Yeah? Okay. So once you have done this, we will use the describe function, and then we will see what comes in describe. So you remember in the summary function that we have earlier, what we had minimum, maximum, first quartile, third quartile, median and mean. So whatever was available in box plot, those are getting printed in the summary function. But if we use the describe function, we have variance, that is given by sorry, not variance, we have the variables like VATs. VATs mean how many variables we are passing through it. So since we are passing only one variable, that is why we are getting it as 1. N gives the number of samples. So in this original data we have 20 samples. So number of samples is coming as N, that is 20. Mean is actually our average. Standard deviation is coming as SD. Median, then trimmed. So basically Tanujit sir talked about outliers, right? That someone is getting 1 crore salary and someone is getting 5 crore salary, sorry, not 5 crore, 5 lakh salary, and on an average people get a salary of between say 30 to 40 lakhs. Now 1 crore is also an outlier and 5 lakh is also an outlier, because usually salary is not as low as 5 lakhs and not as high as 1 crore. So what we do in those cases, we try to get rid of these two values. 5 lakhs we will omit that, and 1 crore is we will omit that, because they are extraordinary, they are outliers and it is not possible to have that outlier. So we try to trim those two values, that is why it is called trimmed. So after trimming those two values, what is our mean? So that is getting printed as trimmed. Now MAD is actually the mean absolute deviation. So we already saw what is variance. Variance is nothing but 1 by n sum over I xi minus x bar squared. So instead of using xi minus x bar squared, we can have xi minus x bar, and that should come inside an absolute, like a modulus sign, right? So basically MAD is the mean absolute deviation, that is 1 by n sum over of I equal to 1 to n mod of xi minus x bar, and it is also a measure of dispersion. Then comes the minimum, maximum as usual, the range, and now comes Q-net, kurtosis. So these are also different measures of descriptive statistics, and the standard error. So the standard error is actually the standard deviation of the sampling distribution, that is a statistic. So we heard about what is a statistic. Statistics is actually calculated maybe sample mean, that is x bar, or standard deviation. So standard error is actually the standard deviation of the sample mean, that is a statistic. So basically as you can see that using summary we were getting very lower number of descriptive statistics, but using this describe function we can get a lot of idea about what are the values of different function or different what do you say, measures of location and dispersion, right? Now coming to the plotting. So we know that in descriptive statistics some measurements are required, maybe our mean, median and something like that, and another portion that it comes is the visualization. So, when we talk about visualization, a very important visualization that comes to our mind is histogram. Histogram is nothing but we plot the values with respect to its frequency. So, for plotting the histogram, we just use the hist function. Hist stands for histogram. So, once you run it through the hist function, and by default it will give a grey colored, but it may so happen that it is, since it is not that presentable or not that good looking, we try to change the color to blue, and you for doing this you just need to pass the argument call equal to blue. You can use any other color of your as you like, you can change it to red or anything, just make sure that it is comes under a quotation mark, and once you pass it through the call function, you see that the color of the histogram has changed. So, till now everybody could follow? Yeah? You are telling yes, right? Okay. So, now comes a dot chart. So, what happens in a dot chart? Dot chart is basically a scatter diagram. So, how dispersed our values are, that is what it is printed. On the x axis you have the credit score, and on the y axis you have the frequency. So, you see that maybe something say 63 appears so many times, right. So, this is where dot chart comes into picture. Now comes box plot. So, we have already spoken about box plot and what box plot depicts. So, once we plot the box plot, and again this is grey colored which we do not like, so we will try to change it to green. Yeah. So, basically can any one of you tell me what does it mean, like that black line represent? Mean or median? How many of you are telling mean and how many of you are telling median? It is median. And this line at the below? This one is Q1. So, basically you have Q1, Q2 and Q3, that is it, and this is the minimum, this is the maximum. So, it will not be the opposite, right, it will not start from maximum end at minimum, because we have it arranged. So, it is minimum to maximum. So, this is what box plot represents. Now, we will come to some other visualization, different kinds of visualization that we will be looking. So, actually I prepared a slide, but I am just going through the course itself. So, I thought that you had a lot of theory sessions. So, okay. So, I was telling you about ggplot, right. So, for you ggplot is that library that gives us very beautiful representation, and I can just show you such graphical representation, and everything can be changed using ggplot. Like you can see that this box, this outside box which is coming over here, you can just get rid of it, you can change the color of it, or you can make it to a different shape, anything can be done with ggplot. So, for using ggplot, since we will be using it for the very first time, the first thing you will be doing, install.packages ggplot. So, before that I think all of you have a hash, so please get rid of the hash and run that code, install.packages ggplot. Once you run that code, then run the library ggplot, that is a ggplot2 actually, yeah. Yeah, it is working. Any doubt, anyone? I assume there is no doubt. So, now we will import a different data set, that is a big mart data set, that is a market data set actually, and there are a lot of items on lot of columns. Like in the previous data set we had only 2 columns, here we have more than 2 columns, and we will see different visualizations of that data set. So, again for importing the data set, we use the read.csv function. Once you run it through the read.csv function and try to print it, so you can see that there are a lot of nearly 83 plus 8440 rows. right. So, what we can do, we can try, if you can see that the entire thing is not visible. So, we can try to print the head, only the first 5 rows of it. For doing that, we need to call the head function head data mat. So, once you call the head of the data, you see that you have one column called item identifier. So, whenever you go to a supermarket, you see that there is some kind of code, unique code associated with it. So, we call it an item identifier, then an item weight, then what is the fat content in that item. Next comes the item visibility, how visible that item is in the supermarket. What is the type of the item, what is its MRP, and then you want to identify the outlet also. So, suppose that it is kind data from different maybe Big Bazaar store in Bangalore, and each and every store will be having an outlet identifier. Then we will be checking the outlet establishment year, what is the outlet size, outlet location, outlet type, and what are the sales that are happening. So, based on this data, first what we will try to do, we will try to see a simple scatter plot of item visibility and item MRP, that we will try to check that whether the how visible of an item is, does it affect the MRP of that item or not. So, for that you just run it to the ggplot item, ggplot function, and this command, that is geom point, okay, this actually tells that this should be printed as a scatter plot. So, you can see over here, right, that MRP are coming in different slabs. So, there are basically 4 slabs, and as the visibility increases, the MRP does not increase that much. Then we can include as different variable in it. So, till now we have plotted 2 variables together. What if we want to understand that if we include a third variable, which is actually a categorical one, whether how it affects the visibility of item. So, we want to understand that whether type of that item is going to affect it. So, if we want to include the item type as well, we just previously we were just doing geom point. This time we will pass the variable, that is item type, in our geom point. So, once we do that, so this is how our scatter plot looks like. Now, you can see that different colors represent different items, like this pink one, not the pink, the violet points, you can see it is very like messed up. So, the violet points represent seafood. Now, it is very difficult to understand from this plot. So, maybe for simplicity what we can do, we can segregate the plot into some portions. So, what if we segregate into some portions, how it is going to look? Yeah, now it is better, right, than the previous one. Now, you can at least say that okay, for this is for starchy food. See, in case of snack foods, the prices are very volatile and this like sale is also too high. There are so many points in starchy food, whereas you compare it with, sorry, in snack foods, whereas you compare it with starchy foods, the item visibility is very low, right? Next we will talk about a histogram. So, now if we want to count the number of items on basis of cost, then we can actually plot a histogram. So, if we run again the hist function, so this is the item MRP and the count actually gives the frequency of the items. Now, coming to a box plot. So, if we want to understand that how the details of the outlet changes with different variability or the different outlet identifier affects the sales in that outlet, then what we can do, we can try to draw box plot for different outlets that are available. So, see, there are so many outlets. There are nearly 1, 2, 3, 4, 5, 6, 7, 8, 10 outlets are there, and you can see, can you tell me, like, for outlet 0 to 7 the variability is maximum, and there are some outliers also in this outlet, right? So, and from this plot you can actually compare which of the outlets are doing best and which of the outlets are not doing that much. Like outlet 019, that is not doing that good, that is basically performing the worst in terms of its total outlet cells, whereas outlet 027 is doing best in terms of its item cells. Now we have talked about correlation. So basically we can use a heat map to check the correlation. So if we want to understand how does this outlet identifier and items type changes with terms of a correlation, what we can do, we can pass it through a correlation, and you can see that as the color of blue becomes lighter, the item MRP increases. So you can use this index, okay. So as the color lightens up, the MRP increases, whereas over here as it becomes dark, the item MRP decreases. So from this you can get a rough idea how the item MRP varies with different outlet identifier and with different items. Now if we want to understand the correlation between different variables, we can use a correlogram. For drawing a correlogram, we require the choregram package. So for doing that, we first will be installing the choregram package, and then we will be passing it through the library function. So if you run these two codes, so any doubt? Oh, can you follow till now? You have some doubts? Okay. Library was not working? So you could run till that, right? Yeah, you didn't install it. ggplot2. Yeah, just 1 minute. It will take some time to install.
It's showing that warning. Is it okay or it's
Warning is fine. It will show some warnings. No, the error is with this. Where is the data set? Where is the file? Open the. You haven't changed your working directory?
No, we asked. We are doing it. You said what is get WD. We told him that it's in C drive download. Then we didn't know how to set the directory. So it's not in that.
So can you open that file?
আমি দেখছি এটা।
So ggplot is installed.
ggplot is installed?
Yeah.
थोड़ा hard.
Yeah, they will need to install it. I told you to change, to remove this and then run it.
No, but it shows error in ggplot.
Before that you have to install it, otherwise it will not be working, right? First you have to install the package, then only if you call it, it will come. Let it get installed, it will work. It's working? It's getting installed. So it's working for you all? So I think you are able to do this installation of CoreGram package also? Yeah? Now call the library function of CoreGram. You did that? And one more thing, if you are getting any warning message, that is not an error, that is a warning, that is okay. Okay, because what happens, some packages are built for different versions of R and it has not been updated, but that does not mean that your code will not work. Okay, your code will work, but R will actually give you some warning that this is happening, but it is not an error. That is a very important thing. So now if we try to use a CoreGram package, a CoreGram function, and we plot how the correlation between the different variables of this data mart data is changing, you see that whatever is coming as white, that are actually 1 plus 1, okay, because all the white values represent the correlation with itself. So so if we have a variable, say your height, and we try to compute the correlation of height with itself only, so it will be positive 1, right, it will be very strong association. And here whatever is coming as red, that indicates negative correlation, blue indicates positive correlation. So you can actually understand from the direction of the lines, you can see that there are some very simple lines over here. Over here on this plot, the lines are very distinct because it is on dark blue. That means that the correlation is very high, it is nearby, very near to +1, that is why it is dark blue. And you are also getting the values of the correlation, corresponding correlation values over here. It is giving you actually the matrix of correlation. So the first item, that is 1.00, is computing the correlation between item weight with item weight. The second one, that is minus of 0.014, which is actually represented on the top first row, second column, that is giving you the correlation between item weight and item visibility, and so on. So I have written some sort of explanation on that, that is it. So that ends the data visualization part of it. So now we will do some very basic pre-processing of data. So whenever you have a data, it is not that good in shape, okay, and you need to do some sort of pre-processing. It may so happen that there are some missing values in your data. Now if you have missing values in your data, do you think that all this mean, median and all, they will work properly? It won't, right? Median will work, but mean won't be working that good, because there are some NA values which will be included in the calculation and it will be giving an NA that is not applicable or not available. So for that, let us import this. There is a file called missing values telecom.csv in our library, in our folder, and if we use a read.csv function to import that, now we will just try to compute the mean of all the variables that are available in this file. So once you do that, you see that you are getting the value as NA, and there is a warning message that this argument is not numerical or logical, and that is why it is returning an NA. That means that you have some missing values in that data, and that is why when you are doing the calculation of mean, this missing value is also being treated in the mean calculation and is giving you NA. Okay. So now what you are going to do now? One way is to take out the missing values and then you compute the mean. Now once you take out the NA values, you can compute the mean in previous way, like just by computing a mean of that variable, and you can replace all the NA values with the mean, right. So this is called missing value imputation with mean or mean imputation. So this is what we are trying to do today. So what we are doing now, we are taking another data frame called new data. And what is new data? New data is actually omitting. You see NA dot omit. NA dot omit means it is omitting all the missing values from it. So new data now doesn't have any missing value. Once you run it, and then you can write.csv will read.csv will import your data set. Write.csv will export your data set in a CSV format. Okay. So as of now, I won't be doing it, but you can do it later. And then I am taking the first column or second column of my data, that is CM usage, and I am assigning it to a variable CM usage, and consecutively the third and fourth column I am taking. Now what I am doing, I am replacing each of the columns, the missing values of each of the columns with the corresponding mean that were present in the new data. New data were free of any missing values. Okay. So how I am doing that? I am just taking this CM usage and I am replacing everything with the mean. Now if you try to compute the mean of CM usage, you see we are getting the value, right. Why we are getting? We are just getting because we have changed all the missing values to the corresponding mean of a without like normal values that were present in that column. Similarly, we are doing for the other. And now if we just bind all these data that were that have been imputed and the other variables of the my data, and then if you see that how our variable looks like. So this is this is our new data frame and it doesn't have any more missing value. So now if we just run mean of my data, I will just check that. So now you will be not getting any more missing value, right? Yeah. Yeah. So what? Okay. So now we will come to random sampling. So we have seen that we cannot collect data from an entire population and we need to generate some sort of samples from it, right. So, this is, even though this is a very small data, and just for showing how the sample works, I will be showing you with this data. So, what happens, I will be first reading this data, supply underscore chain data, and then the so if you just run the sample column, sample argument, then you will see that you are getting it as a new sample. So, you run the number of rows. So, in the previous sample you had 10 rows, okay. Now, if you consider the next sample, you will be having 9 rows. So, this is how, and you can specify the number of samples you want. So, if you have any doubt, you can just use the help function, go to the help function and call the sample. So, this is where sample comes in, and what it does, it actually random samples and permutation. It is a simple function and it takes a specified size. If you do not specify the size, it will just arbitrarily give you a sample, and it is usually fixed to 10. So, now we will come to some applications in testing of hypothesis, okay, and here we will be only focusing on a t-test, but later on you can just proceed for other tests. So, before coming to test of hypothesis, we need a number of packages. So, maybe you can just install all these packages and call the library function very first, then we can proceed with the sim.
So now we are coming to test of hypothesis, okay. Whatever we studied today, for test of hypothesis we need these particular packages, okay. We studied t-test, t-test means test of mean, or high average is let's do some tests. But before that, please install all these packages, because we will be running on this thing. That requires those libraries. Library is a function. Function tells us to incorporate now. Otherwise, you can write your own function. That is too far from my mind. Okay. We will learn that maybe later. So we also write now new functions. Okay. If we have to make our own algorithm. Okay. So please install these libraries under test of hypothesis first. To start this concept. Then she will give a problem. You will try to solve it. Okay. Yeah, Python also can do all this.
So, here,
All these libraries. Yes.
yeah, it is done.
Now she will go to the problem first. What is the problem here? She will then.
So, basically we have a data, and on processing times in call center. So, whenever you call in a call center, they will give you some waiting time, and there will take some time to process your calls and pass it to their next executive, right. So, basically an analyst wants to check that whether the total processing time, total call processing time in a call center is less than or equal to 40, okay. So, basically this is our hypothesis that we are formulating. So, can any one of you tell me what will be the null hypothesis? Sorry? What we are trying to check, that the processing time, because the call center claims that the processing time is less than equal to 40, and someone else come up that and say that no, it is greater than 40. So, what will be our null hypothesis? Equal to 40. And what will be the alternative hypothesis? More than 40. So, we will be doing the same thing over here. So, for that, first read the data, and it is saved as PO processing time data, processing.csv data. and then we will extract. You remember the dollar symbol that we used to extract the variable. So, we will extract the variable using the dollar symbol and save it as PT. PT means processing time. Now, since if you look at, I will just show you the data once, just a minute. So, we are done with all of these. Yeah. So, this is the problem that we are trying to figure out, and I will just show you our data set. Sorry, I do not have the data set over here. So, whatever, like in our data set we do not have the standard or the actual variance. So, if we do not have the variance and we have to do this kind of a mean hypothesis testing, then which test we were using? T-test, right? Yeah. So, since we will be using a T-test, what we will do? We will call the T-dot test. T-dot test will actually implement whatever is required in a T-test. And inside the T-test, T-dot test, what we will pass first? Inside T-dot test, we will pass a variable which we want to test. So, our variable is PT. What is our alternative hypothesis? It is greater than 40, right? So, we will call it greater, and mu is 40 because we said that it is greater than 40. So, once we run this code and everything that was doing that calculating p value, standard deviation, everything that will be completed, and you see what is our p value? This is the p value 0.00011753. So, p value is very less than 0.05, right? So, what we are going to do? Yes. So, we basically reject the null hypothesis and we say that whatever claims the call center was doing, that their call processing time is less than or equal to 40, it is false, and so we take the word of other analysts that it is greater than 40. So, with this, by this we do the T-test. Now, in some situations we need a normality test. Okay. So, what happens in a normality test? Basically, we want to check that whether the data which we have in hand that follows a normal distribution. So, there are various tests for normality test, but what we will do a QQ plot or the QQ norm plot. So, what is QQ norm plot? We heard about quartiles, right? So, this QQ norm plot plots the quartiles of a normal distribution. Alongside, it plots the quartiles of the original distribution. Now, if we see that the plots of the normal distribution and the original data that we have in hand, they collide or they coincide with each other, that means that our data comes from a normal distribution. So, we will check it for the processing time data, and as we can see that it is roughly normal, right, because in the middle it is more or less linear, and in the other regions the data is also very less. Maybe if we would have more data, then we could have supported it.
So, just like we got our heights from a normal distribution, right? We assume that, but who knows, it does not follow. Just like the data will be collected for your experiment may not follow normal distribution. So, how do we check whether it really follows normal distribution? This is for the test. So, this is called normality test. This can be done visually by normal input plot. I told you everything can be done visually, but visually is not the best way. You can do by visually, then you can do by statistical test. So, she is showing two ways to check the normality. Okay?
Yeah. So, for the statistical test, we will be using the Shapiro-Wilks test. It is actually a normality test, and once we perform this test, you see that p value is 0.1418. That means p value is greater than 0.05, or even p value is greater than 0.1. That means that our data actually follows a normal distribution, because in Shapiro-Wilks test the null hypothesis is that the data follows a normal distribution. Okay. So, now we will be coming to the linear regression, how to fit a linear regression to our data. And so, to perform linear regression, we again need a lot of packages. So, first I will say that please install these packages and call the library functions.
So now we try to fit y equal to alpha plus beta. Okay, to our data. How do we fit that? How do we fit a straight line to a data for a given data? Okay.
So we'll be using the DC simple regression data set that we have, and there are two variables, one is temperature, another is DC content. So we want to understand whether DC content can be predicted in terms of temperature. So what is that? Y, that is our dependent variable, we consider as a DC content, and X, which is our independent variable, we consider as a temperature. So we will first assign these two variables into other variables like temp and DC content, so that it becomes easier for us to handle. So first we will start with a scatter plot. So once we scatter plot, you will see that you can easily fit a straight line, right? It is highly correlated and it is nearly +1. It's a very nice data set. So then
this means positive, very strong positive correlation. So you can model this using the another one. You can model this is what is
content.
Dry content using the dry temperature.
Yeah.
So if you check the correlation value, it's coming 0.99, truly correlated. In your real life, it's like by luck it can come. We have created a data so that it comes very nice like this. Okay. Now we'll fit a model. Okay.
So if we fit the model, we will see that we will be using the LM function.
LM means linear model. So y equal to alpha plus beta x is a linear model, right? So we'll fit a linear model. Let's fit it, and then if you see the summary, you will get the model. So the model here, can you please show the model?
Yeah.
So you see, it is fitting a model y, that is D content, equal to alpha plus beta into temperature. Now you may ask, what is the value of alpha and beta? This is the value of alpha and this is the value of beta. You see the estimate of intercept. Intercept means alpha or A, beta means this. So my model now is D content is equal to 2.18 plus 1.29 into temperature. This is your model. So if you have say crop production with say fertilizer amount, so your crop production equal to 2.18 plus 1.29 into fertilizer. So next some farmer will come and ask you how much fertilizer I will give to get 500 amount of crop production. You can plug in the value 500 out there and tell them the answer. Or if she asks that I have this amount of fertilizer, how much I can get, you can put the value there and tell them. That's the best thing about the linear regression model. So this is how we try to model the data. So we were given with this particular data, you have fitted a line to the data. Okay, this is my line. The equation of the line is given like this. So from R, you have to look at these values. Okay, add these values. If you look carefully, you will get the answer. And there is another measure which tells about you how good is the model. If you want to see how good is the model, just look at this adjusted R square or R square value. This actually tells how much amount of variability in the data is explained by the model. How much variability in the data that is explained by the model, that is 0.9983. That is 99.83% of the variability your model will explain. That model in real life never exists. If you just write down the data like this, then that will exist. But in real life, if you get it more than 70 or 80%, you are fine enough. So you will also look at this particular value. Okay? If it is more than 80%, then you say, oh, my model explains so much. My model can capture all the identify the uncertainty. And this is your model. Model means an equation, a mathematical equation derived from the data. Okay. Now, can you try to do the ANOVA of this model?
Yeah.
So this is the ANOVA of the model. What does it say? It says that temperature, this is the p-value. This is the last value is the p-value. Star 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 means p-value is less than 0.00000002. Okay, very very low. What do we mean by that? What do we mean by p-value to be very small? That is, temperature is a significant contributing factor to the decontent. That means the data I have collected is not worthless. It's very worthy data that my temperature can really reflect what is the decontent going to be. So by ANOVA, I check that this temperature, whether it contributes to the actually in performance of the response variable. Response is decontent. Temperature is a very contributing factor in the decontent variable. Okay. Now you can plot the residuals. That is, this is my model, this is my real data. What are my residuals? Residuals means the difference between them. How the difference between them look like. If we see,
So this is actual versus prediction.
no, can you plot the residual?
Yeah.
Plot this. Capital R is. So you see, R is very much like if you put capital letter and if you put small letter, it makes a lot of difference. So you have to put the, if she puts small RES, then it will not work because capital RES is defined. So the RES is defined as like this. That means what? This error is called random error. Random means random movement, right? There is no pattern out there. That means the errors, the model could capture actually the inherent variation in the data. That's why the errors become random. Otherwise, the error will have a pattern. Okay. And now, if you plot the decontent and the predicted value together, it will look like this. So it will come down to a straight line. So your prediction and the actual value, they are very close by, right? If you plot 1, if your value is 1 and you predicted 1, if your value is 2, you predicted 2, then it will be a straight line, 1, 2, 3, 4 like this, right? So just like that, whatever your values, your predictions are very close by. Then you can check the normality of the residuals. So in linear regression, you assume that the model that will be built, that residual, that is your prediction versus the actual value, their differences is going to follow a random behavior. That is coming from a normal distribution. Normal is the random behavior here. So we can do the, by plotting QQ plot, I can see that. Can you
Yeah.
try the QQ?
This one.
So this is the QQ plot, and also by Shapiro yield test we can confirm that. Okay. So then now your question will be, now so far we have been uploading some data. What if I want to write my own data in R? How do I write my own data? Okay. Now she will explain another example.
It's the same
With
example.
the same example by writing the data. To write the data, what you have to do? You have to create 2 columns. Column means you have to create 2 vectors. Vectors are created in R by this C. C means combine.
Concatenate.
Yeah. So by C, we create a vector which is nothing but a vector of D content within a data frame. Data frame means is nothing but in Excel, whatever you create is called a data frame. X, Y, a data frame of 2 plus some 2 rows, multiple rows and some 2 columns. Okay. So 2 column will be created. One is D content. So it will create like this. It will create a D content and it will create something like temperature. It is created, if you put C bracket some values, it will be put into row like column wise. Okay. So it will create value 73.3 and there it will be created as 55. and next one will be created 74.6, and it will be 56, and blah blah. So this is how you can also write your data in R. Okay, it is also very important. So then you can also do the same stuff here.
Just the same thing that we were doing.
Most of the same.
Yeah.
So I think you have learned a little bit about how to do descriptive statistics. What are the descriptive statistics tool we learn? We learn two ways of understanding descriptive statistics. One way is by visualization. We studied histogram. We studied histograms means the plot, right? Frequency plot. We studied the box plot, which gives us 5-point summary, which is very helpful to check between the two different cases, before and after, how much changes is happening. Then we learn scatter plot, the plot of the correlation, from where we can figure out the correlation. And we also learn something called some other plots. Did we learn dot plot, all these other plots that was given in the cheat sheet. Then we learn how we deal with different statistics. Statistic means how we collect the data, and from the data we get the measure of location, mean, median, mode. How do we collect the scatteredness, sample range, standard deviation, variance, variation of the data, shape of the data, skewed data, Pareto distribution, income distribution, right? Or our height is normal distribution. Then we learn how do we get the correlation between two variables. We calculate the correlation by scatter plot, we calculate the correlation by the correlation measurement, R. If it is positive 1, it is highly positively correlated, negative 1, negatively correlated. If it is greater than 0.5, there is a possibility of correlation. But we also saw an example of dinosaur with different images coming. We can get sometimes similar values of the mean, variance and everything for two different data sets, different plots coming, right? The dinosaur came and many other things came, right? Then we learned Galton's board, right? In which if you put lot of binomial variables, for last sample it becomes normal. So it's like the center limit theorem of the data. That is, any data distribution for large n can be approached to asymptotically to normal distribution, right? Then we learn some ways of inferential statistics. We divided statistics majorly into two sections, descriptive and inferential. In inferential statistics, we learn two ways of handling data. How do we handle the data? We calculate statistic from the data. What is statistic? The function of the sample. That is mean, variance, all this stuff. Then the distribution of statistic is called sampling distribution. Based on the sampling distribution, we can create different test statistics, right? For test, we learn what is null hypothesis. Someone coming with an assertion, some very strong belief that is available. If you want to challenge those beliefs, you create some alternative hypothesis. What is the type 1 error? We discussed with the airport, with the car entering the airport example, right? Then type 2 error. Then we learn about p-value. How much confident I will be to reject the null hypothesis. Then we learn a few tests. Z test, T test, these are useful for mean test. Then variance test, F test, chi-square test, right? Then we learn a few things called how to get the estimate. How many ways we can get the estimates of the parameter. We can calculate your average value based on by taking simple average, or we can do in many ways. What is the best method of estimation? We understood maximum likelihood estimation. We discussed about maximum likelihood estimates. And then we talked about interval estimation as well. Maybe the parameter value sometimes may not be a point value. Maybe tomorrow's temperature, if I predict 23.97, it is very like not going to be happening. I can tell 24 to 26. So how do we make the interval estimation? And then we went to the establishing the relationship between the independent and dependent variables. Suppose you are working in agriculture, you want to establish the relationship between crop yield versus the temperature, the amount of fertilizer you are giving, the amount of money you have invested, all these things. How do we make the relationship? By regression analysis. We discussed about linear regression model, and we tried to implement them. Okay. So more or less we are coming to the end of the session. Before ending, before I let you ask a few questions, whatever you have, before that I'll tell you about some of the very important websites for all the researchers to follow. I already gave you what are the books to follow for statistics. Right? Now I'll write down a few important websites for you.
Yeah.
So also, just a minute.
So you
This
you
R
need the mic.
implementation. No, I don't need. This R implementation, it has a helping slide also with that. If you go, can you show the
Yeah.
slide as well?
I have shown
All
them.
these things, details are given in slide. So in case you forget, you look at the slide. Then you will be coming back to here.
Yeah.
So this is the slide she prepared for you to understand. Okay? All the things are given in details. I talked about the theoretical stuff. If you go through, you'll get the practical stuff. And all these things are available in the website that we have given. And it will be available forever. So if you miss now, you can download it later and try to work on it. Can you see this board? Okay. Maybe this is one of the common questions many people asked me earlier. Here